Determine the number of integers between 1 and 2022 inclusive, so that means including the 1 and the 2022, that are divisible by 11 or divisible by 13. So let's see how many are divisible by 11. So we're just going to divide 2022 divided by 11 gives us 183.81, so on. And that means that we've got 183. And then we're going to do 2022 divided by 13, and that will tell us how many are divisible by 13. So divide that by 13, and we get 155.53 and so on. That means there's 155. Now, we can't just add them because, of course, some numbers will be divisible by both 11 and 13. So 11 times 13 is 143. So we need to find out how many are divisible by 143. And they'll have been counted twice if we add these up. They're counted here and they're counted here. So what we're going to need to do is take these out. So we've got 2022 divided by 143, and that gives us 14.13. And that means 14. So we're going to do the 183, add the 155, take away the 14 that we counted twice by just adding the other two numbers. So 183, add 155, take away 14, gives us 324. Codes such as HFF and GDC are made by randomly selecting 3 letters from the first 9 letters in the alphabet. Determine what fraction of all possible codes contain repeated letters. So let's think about the total number of codes. So if we're allowed to repeat, there's 9 choices for the first letter, 9 for the next, and 9 for the next. And that gives me 729. Now let's think about the ones where there's no repeats. So we've got 9 choices for the first. We're not allowed to repeat. There's 8 choices for the second. And once we've chosen 2, there's 7 choices for the third. So that's 504 that have no repeats. If we do 729, take away 504, that's 225. So those 225 have some repeats. So we've got 225 out of 729 have repeats. And we can simplify that. 225 divided by 729, or at least if it does simplify, this will do it. And that is 25 over 81. Determine the number of different ways that the digits in the number 9873528 can be arranged so that all the even digits are next to each other. If you look at the number, the even digits are 2, 8, and 8. For 3 different digits, you can rearrange them 3 factorial ways. The fact that we have 2 the same means these can be rearranged 3 factorial divided by 2 factorial, which is 3 different ways. And now we just consider that to be one single block. The odd digits are all the same, and there are 4 odd digits. So we're arranging 5 things, the 4 odd digits and the block of even digits. So that's 5 times 4 times 3 times 2 times 1, which is 120. So there's 120 ways of arranging the block and the 4 odd digits, but the block can be rearranged 3 ways for each of those choices. So 3 times 120 is 360.